Hey, hi, children. So, welcome back. And there's been a lot of requests that I have received in terms of, that the first term exams are coming on. And वैसा ही होता है that we must have not done our studies that properly happens. It has to happen with us also. So, why not a crash course video on a specific chapter? We'll not go that deep, but we will go into a level of theory coverage which would be enough for you to understand, considering the time that is left for you, understand the theory and how to apply that knowledge into your exam style questions that I might be expecting. So this series is for physics and we would be starting with, say, laws of motion. And we cover up the basic theory that is required for laws of motion. And along with that, we will also be doing our question answers and practice, which will give you a fair bit of ideas, starting with simple problems at first, and then going and scaling our problem levels to one level higher. Questions will be usually from typically the ones worksheets available on internet, and we'll also focus on questions from Lakbir Singh and Manjeet Kaur textbook. And if time permits, we'll also take some H.C. Verma fundamentals of physics questions, right? So let's get on and understand basically the first fundamental basics that we need in order to proceed in this chapter, right? So let's join us. Now, in order to understand our chapter about laws of motion, the first thing that we would be needing is to have your grasp on motion. So unless and until motion is clear, we will not be able to get on to our this particular chapter, which is called laws of motion. So let us have a quick summary, a very quick summary on the chapter called motion. Now, when somebody says motion, I don't call it motion. I would say it is the chapter that you studied first was uniformly accelerated motion in a straight line. This was the chapter that you studied. Now, why I call this chapter's name in this manner? Because a lot of information is hidden here itself. So let's say uniformly accelerated motion in a straight line. So it's a straight line motion. That means all questions that you will be getting in this chapter with perspective distance are same as displacement. Because what is displacement? That is distance in a straight line, shortest straight line distance in a shortest distance between 2 points in a straight line. So since this is a straight line, all distances can be interpreted as displacement, which gives rise to your first quantity called S. After that, we have got something called uniformly accelerated. That means acceleration is present, which is A, and this A is always constant. A means constant because it's uniformly accelerated. Now, if acceleration is present, to give birth to acceleration, there should be some parents. What are the parents? Let's see. The parents would be change in velocity, and time, because acceleration is said to be change in velocity over time, right? So this is t, and let's call this as delta v. Now, what is the formula for change in velocity? Change in velocity means velocity has changed. So if velocity has changed, there should be two types of velocity. One should be a initial velocity and one should be a final velocity. So the final velocity is denoted by v, the initial is by u. So your formula now becomes v minus u by t, which is a. So now just cross check. In this chapter, what all do you have? You have a displacement, which is called s. Then you have an initial velocity u, you have a final velocity v, then you have an acceleration a, and above all, you also have something called time t. This in higher classes from now on will be called SUVAT. And SUVAT gives rise to SUVAT equations. There are three SUVAT equations that we read about in this chapter. So whenever you apply SUVAT equation, going further in say in class 11, you're doing problem on kinematics and you want to apply SUVAT equation, first thing that you should be sure about is whether these criteria, and above all, is this criteria being satisfied? That is your motion in a straight line? Is the acceleration constant? Only then please apply SUVAT. Otherwise, don't blindly go and apply SUVAT. So what are my SUVAT equations? Let's see our SUVAT equations. Our SUVAT equations are V is equal to U plus AT. I would not go here into deriving this equation, but you should know V is equal to U plus AT. S is equal to UT plus half AT square. And the third one is V square is equal to U square plus 2AS. These are the three equations. Based on three equations, and this knowledge, then we start our chapter of laws of motion. Because in laws of motion, we will be also interested how the motion happens. In this chapter of chapter 1 that we did, we were not interested of how the motion happened. We were more interested upon the parameters of motion, that if there is an acceleration, how much is the acceleration, what is the initial velocity, who caused the acceleration was never our perspective. Now that perspective will be there in chapter number 2, laws of motion, which will start. So if you take some time to copy this down as a shorthanding note, you can copy it down, and then we resume back with our ready reckoner for laws of motion. All right. So if you have copied this, let's get into laws of motion. Now, what does the chapter hover about? Laws of motion. इस chapter में क्या क्या है? What does this hover about? This chapter will initially give you a glimpse about Newton's laws of motion. Newton's laws of motion. We won't be covering definition or theory part out here. I'll just take up the portion that's enough to solve your numericals, because this is a crash video. And I'll say a level 0, because Newton's laws of motion actually makes you understand what is force. But the irony is that you don't understand the Newton's laws of motion if you do not know what is force. So you should also know what is force. It's like a chicken and egg story. You should know a little bit of force and the properties of force. Force and its properties, rather I would say the effects of force. Now what are the effects? Force can change the direction of a moving body, can bring a body from rest to motion, motion to rest, can change the speed of a moving body, can change the shape of a body. All this theory you have to read. So force, the properties and effects of force. Then comes Newton's laws of motion, which makes you understand what is force. That's basically law number 1. Law number 2, once you have understood this force, the second law tells you how to quantify this force. How to quantify this force. And so far, when you will be understanding this force will be always exerted on some body. That's how the laws are explained. The force acting on a body, the force moving a body. And third law, what happens? You give power to this body. The body will also exert a force, right? Which we usually call the reaction force. So the force exerted on some body, this force will be known as the action force, and the body will exert a force. This is called the reaction force. So this comes in your third law, which will be known as action reaction pair, right? Action reaction pair. This is what Newton's laws of motion will cover you. Now, while you are understanding the second law and you're trying to quantify force, you will also come across a topic in this chapter called momentum. Momentum. And with momentum, you will also get to know about a topic called impulse. The first law is more theory. So when it is theory, you should also come across a term here called inertia. Okay. This is the gist of your second chapter. Your second chapter talks all about force and properties of force. Well, why you're talking about force is because this is the force which is going to make that motion happen, whether the motion is a uniform acceleration motion, uniform retardation motion, or whether there is no acceleration at all. Whatever we studied about in chapter 1, that the reason for that motion will be understood in this chapter. So you will be understanding about force, Newton's laws of motion, 3 basic laws, and just try to understand what those laws tells us. The laws tells us what is force, how to quantify force, and is force always exerted on a body, or does the body also exert a force? We'll understand whenever you exert a force, the body also exerts a force, known as the action reaction pair. And to understand the first, we'll also understand something called inertia, and to understand the second one, we'll also understand something called momentum. Not be discussing so much about first law out here in this crash course, because we'll be doing numericals, but whenever in a numerical some sort of application of this will come, I'll just touch down those snippets that is necessary to understand or interpret Newton's first law, right? So you can copy this section also if you're interested. And then we go ahead with our next section. To understand and do numericals, you should always be thorough with what is the system of units in which you are doing problems. We usually do our problems in SI units. So you should know that the quantities that you are dealing with, what are their units in SI system, and also you should know how to convert. So some of the basic handy tips which you would be needing either for chapter number 1 or chapter number 2 would be some conversion of units and conversion factors. So let's first focus on that. Okay. Now, when we talk about length, in SI system, we would be using the units called meters. Okay. And when we talk about time, we would be using the units, that's second. Meters and second, we write it as M and S. Now, you would be encountering a quantity called speed, and speed is the ratio of distance over time. So what is the ratio of distance over time? Your distance is nothing but some sort of a length measurement, and time is time. So ideally, your SI unit should be MS, that is meters per second, written in this manner, or in the exponential order in this manner. Now, when you will be getting problems, you get a problem that a car is moving with the speed, or a truck is moving with the speed, or a train is moving with the speed. Okay, as I talk about speed, the unit of velocity would also be same. So velocity's SI unit will also be meters per second, or you can write it as ms to the power minus 1. But when you get problems, usually this speed will be given to you in kilometer per hour, because they would try to test whether you know the conversion from kilometers per hour to meters per second. Now, if you don't know the conversion factor, you can apply your conversion skills also. 1 kilometer per hour is same as 1 kilometer divided by 1 hour. Okay, and 1 kilometer means, kilo always means 1000, so that means 1 into 1000 meters divided by 1 hour. 1 hour is 60 minutes, which is equal to 1000 meters. So 1 into 1000 is 1000. 1000 meters divided by 60 minutes means each minute is how many? 60 seconds. So 60 minutes into 60. Now this whole thing is second. So this can be written as 1000 divided by 3600. Now just take away 2 zeros from numerator and denominator. All you're left with 10 by 36, 2 5s are 10, and 2 18. So it leaves you into 5 by 18 meters per second. So what does this give you? This gives you a conversion factor, which you can use directly in your problems, that 1 kilometer per hour is same as 5 by 18 meters per second. And if you want to do vice versa, that is, if you want to bring it from, say, 1 meter per second, so 1 meter per second would be 18 upon 5 kilometer per hour. This is the first thing that we should know, right? You can copy it down. So this is very handy. Once you have known this, then we are in chapter number 2. So we'll be dealing a lot with force. So let's understand the mathematical part of force. Now, force as an expression will be given as rate of change of momentum. This is basically the second law of Newton. Newton's second law, which says that force is rate of change of momentum. Rate of change of momentum. Right? In order to understand rate of change of momentum, first let us understand what is momentum. Momentum is a vector quantity. Now, what is a vector quantity? Quantities which need both dimension as well as direction to specify them. Not dimension. Quantities which need both magnitude and direction to specify them. These quantities, you have to give what is their value as well as what is the direction. Momentum is the product of mass and velocity. So velocity is also a vector quantity. So whatever is the direction of velocity, the same would be the direction of momentum also. So momentum we write as mass into velocity. Now this is the magnitude. So what should be the unit? Mass is always expressed in kg and velocity in meters per second. So the unit of momentum would be kg meter per second, or you can write it as kg meter second minus 1. All means the same, right? So we have understood what is momentum. Now it says rate of change of momentum. That means our next part is this momentum is undergoing a change. That means, and from there we say change in momentum. Change in momentum. So when momentum is changing, definitely there should be two values for momentum. There should be some initial momentum and one final momentum. So we call it P initial as Pi and P final as Pf. And any change in physics is always final value minus, final value minus initial value. So the final value would be final momentum minus initial momentum. That's change in momentum. So let's see, we have now understood what is change in momentum. We need to understand what is rate of change. Rate means when you are comparing one quantity with another quantity. You basically want to see that if one quantity changes, how does the other quantity change? Like if you are changing, say, the quantity of mangoes that you buy, how is the price that you're supposed to pay changes? So when we say rate of change of momentum, we are trying to see what is the change in momentum with respect to time. When time changes, how does the momentum change? You have already covered the rate of change of displacement velocity, rate of change of velocity acceleration, rate of change of momentum, but that's what we're going to study. Force is equal to, or it says, exact definition of second law is not equal to, it says force is directly proportional to, rate of change of momentum. So here we are comparing change in momentum, that is P final, bear with me children, P final minus P initial. This is my change in momentum. Rate of change of momentum, we're comparing it with change in time. So we'll say with respect to change in time. And let's say the change in time is T. T is the change in time, right? So this is directly proportional to Pf. Now what is Pf? Mass into final velocity minus mass into initial velocity. This is initial momentum, and change in time is T. So it should be directly proportional to. Now, when you're in grade 9, you usually don't deal with problems where the mass is also changing. Now, this is the change that you'll see when you go to grade 11. In grade 11, you'll see mass also changing. But that actually happens because if you see examples like a rocket propelling upwards. Now, how does a rocket propel upwards? As it propels upwards, it also loses its fuel. So the mass is changing over time. But in grade 9, the type of problems you do, as if the velocity of the body changes, the mass of the body does not change. So we keep mass as constant. Here we take mass as constant. Remember children, this definition is situation specific. This is not exactly what is the definition of force. This definition of force holds good only when the mass is constant. So you take mass out as common, it becomes V, this is U, V minus U divided by T. And you are aware of V minus U divided by T. This quantity is change in velocity divided by time. Change in velocity by time, which becomes acceleration. So all you arrive is force is directly proportional to mass into acceleration. Now, if you want to equate this, you have to bring out a constant of proportionality K, then MA. And the value of K is taken as 1 when you are doing the system in SI units. When you are doing the problem in SI units. So your force becomes equals to mass times acceleration. Now let's see the unit. The unit of mass would be kg. The unit of acceleration would be meter per second square. And this unit is given the name as Newton. 1 Newton. So how do we define 1 Newton? We say 1 Newton is the force which, when acting on a body of mass 1 kg, produces an acceleration of 1 meter per second square. In which direction? Along the direction of force. See, it should be very specific. Newton's first law actually defines force. And if you ask me, sir, does it mean that first law does not give us any sort of mathematical relation? It does. It does. And that's like a conceptual relation. First law states that in a system, if you find that there is a net force acting in a system, net force means see all the forces acting on the system, try to take their result and cancel each of the forces, and then if you find finally that yes, there is a net force. Give an example. Pull my ear with 5 Newton on this side and 10 Newton on this side. What is it? It's same as pulling this ear with 5 Newton. So that's called net force. So when you have a net force acting on a system, that system will also give rise to a net acceleration. And the direction of this acceleration would be same as the direction of this force. How to understand it? Let's say Right now, your body is facing a braking force. Braking force means the force is opposite to my movement. I'm moving this side, the force is coming this side. It's a net force that is acting on me. So there should be an acceleration also in this direction. I want to move this side, the acceleration is opposing me. So if I try to do the problem of the acceleration with my side, how does the acceleration become? Negative. The acceleration is from that side. So if I view it from this side, the acceleration is negative. That's why a braking force produces deceleration or retardation. Trust this factor is clear, because this is something we would be using a lot. We would be using a lot in solving problems. So what are the takeaways from the discussion of this part? Force is equal to mass times acceleration. 1 Newton is equal to 1 kg into 1 meter per second square. This is in SI system. If you are interested to do a problem in CGS system, or suppose if you are asked to do, then Newton changes to a unit called dyne. 1 dyne would be 1 gram into 1 centimeter per second square. And the conversion from Newton to dyne, well, that's also very easy. If you are interested, we can do it right here. What do we do? Where do we do? We'll do here. 1 Newton is equal to 1 kg into 1 meter per second square. Okay. So what is 1 kg? 1000 grams into 100 centimeter per second square. 1000 into 100 gives you 10 to the power 5 grams centimeter square. So 1 Newton is this, which is equal to 10 to the power 5 dynes. So you should remember this also. Right? 1 Newton is equal to 10 to the power 5 dynes. 1 dyne is 1 gram, 1 centimeter per second square. So whenever you see a problem that we will be taking up now, you should see whether there is a net force acting on the system. If there is a net force, there is a net acceleration, and the value of this net acceleration would be given by the force upon the mass of the system. Force means the net force upon the total mass of the system. Once you get this A net, we will start marrying it with the Suvat equations. As long as the motion is a straight line uniformly accelerated, and the motion that will be given to you for these problems will be straight line uniformly accelerated. That's how they will marry chapter 1 and chapter 2. So from chapter 2, the problems will generally hover around finding acceleration and then plugging that acceleration into chapter number 1, finding other parameters, or getting acceleration and trying to calculate what is the force. So you should know how to calculate force, you should know how to calculate momentum, you should know how to interchange units, and chapter number 1, that's all about Suvat. So let's see this next section where we take up now problems typically of these types, right? So we take our problems. We'll first go with some basic easy problems to make our understanding clear, and then we take some 1 or 2 more complicated problems which will help you to attempt the problems on your own. See, the fundamental is you have to understand, then you have to absorb what is the content all about, and at the end of the day you have to do the problems on your own. We give them, all the teachers will be there to guide you, right? So let's take our first problem. So when I edit this video, what you'll find is that the problems will be actually scrolling in the bottom portion out here. So let's take our first problem. So the first problem is about calculating momentum, right? Because I'll be referring a textbook or I'll be referring a question paper out here, but the problem keeps on rolling at the, has a banner on the bottom. So it says that we need to calculate momentum, and the mass of the man is given and the velocity of him is given. Now, do not first mistake that people do in physics is that they look at the problem and they just start, you know, fitting the formula. Do not fit a formula. Do not first fit the formula. First try to understand what is being requested from you, and we'll get by the CBSE method. In CBSE, steps 2 have a lot of weightage, so it's all about, you know, given data, then the formula, the substitution, as well as the units. So let's see how to do the solution of this problem in the proper manner. Okay. Now, we'll first write what is given to us, because in that way, the examiner gets to understand that this child has a thorough knowledge. Please don't use P equal to mv. What is P? P can be pizza. You know P is momentum. No, the examiner will not check that way. The examiner will read your chronology, and then he or she should understand that this child knows how to do the problem. And there are psychological factors also, like you and me have irritation, frustration. Examiners check so many copies. They also might be having their irritation and frustration. So why don't you present them with your answer booklet, which like sets the mood for the start of the day, right? So given data. So first we'll say what is given to us. We would write mass, and with mass we put the small m, so that henceforth when we are using m, the small letter m, nobody has an ambiguity what is m all about. So the mass is 75 kg. Okay, the mass is 75 kg. And then what you are given is the velocity. Velocity, and we represent it with the letter v. The velocity is given to me as 2 meters per second. 2 meters per second, right? Then you write to find what you have been asked for. So you say to find momentum, and denote the symbol for momentum or put a question mark. You don't know about it, right? And then comes your workout. Now, before you start your workout, you would first write your formula. You write using the expression P equal to mv. Now nobody can stop me from putting P equal to mv, because I know what is P and what is m and what is v. Then have a check at this stage. Also have a check whether the units are the way you want it. Yes, this is in SI, this is in SI. Using the expression you write, right? This is or. Don't put equal to. This is or it stands for implies that. Implies that P should be equal to, what is the mass? 75 multiplied by the velocity 2, which is equal to 100 and or at this stature, many children, if you want to follow this, you can follow this way also. 75 kg multiplied by 2 meters per second, which gives me 150 kg meter per second. That's the answer. So you write answer, you write your answer. Momentum is equal to 150 kg meters per second. We're done. We're done. Absolutely in the manner in which the problem should be done. Follow this procedure. Given data, number 1, given data, followed by what is to find. Number 3 is your formula. Number 4 is where you are substituting, and number 5 release the answer. Sometimes in problems you would find that this calculation is very cumbersome. It's taking a lot of time. By that time I can do one more problem. Please leave it at this stage. Ensure that the units are correct. You might get a half mark less, but it's still better, because who knows, the next question you might be able to solve fully and get full marks, rather than spending your whole time fighting on this half marks. So that's how you do your problems, right? So this was an easy problem. Let's go and take some more problems of same type, right? Our next type of problem, as you are seeing right now, it talks about how to equate force, acceleration, and mass. So let's try to solve this problem. What is the solution to this problem? Okay, let's see what are the given data. We'll follow the same way, given data. So what is given to us? It says what force would be needed to produce an acceleration. So definitely acceleration is given to us. Acceleration. And you write A. The value of acceleration given to us is 4 meters per second square. 4 meters per second square to a body of mass of 6 kg. So the mass is equal to m, which is equal to 6 kg. What have you been asked to find? This is also easy series. In these problems, don't focus that sir is doing easy problems. I'm trying to make you understand how to do the problem. To find force, that is F required. Force F required. You don't know. So you use the expression using expression. So what is the expression we're going to use? Force is equal to mass times acceleration. You're using this expression. Force is equal to mass times acceleration. And now you start substituting your values. So F should be equal to, how much is the mass? 6 kg multiplied by an acceleration of 4 meter per second square, which gives you 24 kg meter per second square, which is same as 24 Newton. So you write your answer as force is equal to 24 newtons. That's it. All right. So this is how you do problems with the way in which the examiner would like to see your problem. Again, we have gone by our steps. Step number 1 is this, and then step number 2, was our expression. Step 3 was this. Step 4, answer. And most important, the unit should also be there. Righto? So let's take another question. Okay. Now this question is a little bit interesting. It says, calculate the force required to impart to a car a velocity of 30 meters per second in 10 seconds starting from rest. Mass of the car is so and so. Now these are the problems that I like. And in these problems, before starting with the problem, your first step should be diagram. Your first step should be a diagram, because a picture speaks 1,000 words. More clear your diagram is, okay, get some pens running down on the ink on this pen. So more clear your diagram is, more is your understanding about a subject, and more of that particular problem that has been asked to you. Now if you look at this problem involves a car. So let's just try to illustrate this problem. So we have a car. Let's say this is your car. Now you would ask, sir, in exam, will I get time to draw this diagram? You may not get time, but you can make some basic diagrams so that it is understood. So we have a car, and this car has a mass of 1500 kg. So this car has a mass of 1500 kg. Okay. And this car is starting from rest. If you see, the car starts from rest. So let's say right now the car is starting from rest. For us, rest means the initial velocity of the car should be 0 meters per second. And then it says, what is the force required to impart to a car so that it catches up a speed? It's going to catch up a speed. And how much is the speed it's going to catch up? It's going to catch up a speed of 30 meters per second in a time of 10 seconds. So obviously, what we need to do is that we need to give a force to this car. We don't know what the force is. And after giving this force, this car must have gone somewhere else. So I'm not drawing the car once again. I'm just drawing this rear wheel of the car. So the rear wheel of the car has now come here. And at that time, the velocity, there's the final velocity is 30 meters per second. 30 meters per second. And this particular increase in speed, the car is supposed to pick up this increase in speed in a time interval of 10 seconds. That's it. How much force do you give to the car? A car whose mass is 1500 kg, so that the car picks up a speed of 30 meters per second starting from rest, that's 0 meters per second, in a time interval of 10 seconds. Right? So are we in a position to do this problem? Let's see. So as usual, we would first write what is the given data to us. So first we'll write mass m, which is equal to 1500 kg. Okay. Then initial velocity u is equal to 0 meters per second. Final velocity v is equal to 30 meters per second. Time t is equal to how much? 10 seconds. That's all. Any other data given? No. And then we write to find, we have to find the force. The force is F, which is equal to, this is what is the question all about. Now start thinking. Chapter is all about laws of motion. So the first thing that comes to your mind is, what is force as per laws of motion chapter? Mass into acceleration. Is the mass given to you? Yes. Now what is the force? The force is acting in this direction. The force is acting in this direction. So I can understand from Newton's first law that this is a net force acting. And if a net force is acting, then there should be a net acceleration. And if the net force is acting in this direction, the acceleration should also act in this direction. Is it happening like that? Yes. That's why your velocity is increasing. And it is increasing in this direction. That means the force is acting from behind the car. Think like that. So we don't know what is acceleration. Now go back to your Suvat equations. Is the motion in a straight line? Yes, the motion is in a straight line. What does acceleration equal to? V minus u by t. We get it from the first equation. So first equation is something different. It's nothing different. It's the same thing. V is equal to u plus at, which gives you a. So we have our entire problem is solved in rough sketch out here. So what do we write? Now we write a solution, right? And in solution, we would write using expression F is equal to ma. Now see, a you have not defined out here. Where you write a is equal to acceleration, which is also equal to v minus u upon t. Okay, now you can use it. So F is equal to, what is the mass? Then further you make it m into v minus u by t. So you write F is equal to, what is the mass? 1500 kg into v is how much? 30 minus 0 divided by 10. This is acceleration, so it is meter per second square. So finally it becomes 1500 into 3 kg meter per second square, which is equal to 4500 Newton. So answer, force is equal to 4500 Newton. That's how we solve a problem. This was the most important part according to me, because if you start developing the habit of drawing a diagram from now onwards, you will go a long way out in solving numericals when you go to grade 11. Because remember, none of these chapters you're going to study in grade 10. Everything comes back in grade 11 after 1 year. And at that time, you would be with some additional coachings and additional institutes where the workload will be very high. So a habit that you inculcate right now at this age was helping you along later. But that time, free body diagrams and other things will come. So have the habit of drawing diagrams. Fine, children? Okay. So the basic idea was how to solve problems, how to illustrate problems and do them. We'll take one more problem and check that out also. Okay, right. So let's take one more problem. It says, a car of mass so and so is moving with a velocity so and so and is to be stopped, in so and so seconds on applying brakes. Calculate retardation and the retarding force. Now this is interesting. Okay, so let's again draw a diagram. So we have a car. So we have a car. We're drawing a lot of what you call maybe sedan. So we'll make some SUVs. So this is our SUV. Okay. Now let's see what is given to us. Now a car of mass 2400 kg. So the mass of the car is 2400 kg. Now this car is moving along this road, and this car is said to be moving with a velocity of 20 meters per second. Okay, let's draw an axis line out here and say that now this is the initial velocity of the car, 20 meters per second. Now this car has to be brought to a stop, or it is brought to a stop. So I'm drawing the front wheel again out here. Now the front wheel's velocity has become 0 meters per second. It has been brought to stop because here the car was in motion, and here car has come to a stop. Okay, has to be brought to a stop, and the time taken to bring the car to a stop, the time taken from here to here is 10 seconds. In 10 seconds, the car has been brought to a stop. By applying brakes, calculate retardation and retarding force. Now just understand the problem again from Newton's first law perspective. Now what happens is, what was one of the effect of force? Force can bring a body from motion to rest. This is exactly that. Force can bring a body from motion to rest. Now, if the body is being brought to rest, our understanding now tells us that the force is acting opposite to the direction of motion. So this is my F net. If this is my F net, then the acceleration or A net must also be acting in this direction. Now here is the understanding. Children get confused, sir, I got plus, I got minus. You did not think like that. Now the force is acting in this direction. The acceleration is also acting in this direction. The acceleration is acting in this direction. Now think that you are the observer, or you are the guy who is driving this car. Now for you, how is the force from your perspective? From your perspective, number one, the force will always be negative. Force is a vector, and the force is acting in this direction because you believe, you go by the Cartesian coordinate system, you believe anything this side is positive. Now the force is on this side, so the force has to be negative, and for you the acceleration will also be negative. This is This is the thought process. The acceleration will also be negative. And a negative acceleration in the language of physics is known as retardation. And if that is retardation, then this force, which is also a negative, will be known as my retarding force. So have your concept clear. Do not just think that, sir, I got a plus or I got a minus. Now let's solve this problem. Typically in our order solution. So what is the given data? Given data, as usual, mass m, and the mass is how much? 2400 kg. Okay, then what is given to you? Initial velocity. Initial velocity u is given as 20 meters per second. Final velocity is given as v, which is equal to 0 meters per second. Anything else given to us? Yes, the time is also given to us. Time is t, which is equal to 10 seconds. Okay, I'll change the pen. Time t is equal to 10 seconds. Now just check up whether everything is in SI system. Yes. To find, what am I asked to find out here? Number one, the retarding force, which is F, and I don't know. I've shown the retarding force out here. Now, if I'm talking in terms of retarding force, numerically this force should come negative. Okay, and they have also asked, okay, and the retardation, and also the retardation. And I would write retardation as the negative of acceleration, which is equal to unknown, right? You can write it here also, or you can leave it. So our wish, we have written retardation as negative of a, but the problem is you have not yet defined a. So we'll leave here and we'll just write what is the retardation is unknown. So let's start using formula. So first what we say, using expression, let's use the expression F is equal to m into a. This is known, and here I write a is equal to acceleration, which is equal to v minus u upon t. So can I write my F to be equal to m into v minus u upon t, right? So they've asked me to find the retarding force. So let me calculate the retarding force. In fact, they've asked the retardation first. So let's calculate the retardation first. So we will calculate our A is equal to v minus u by t. What's the value of v? 0 minus, moving at a speed of 20 divided by 10, which is equal to negative 20 by 10, which is equal to negative 2 meter per second square. So we write here as A is negative, therefore it depicts, therefore it depicts retardation, which is equal to 2 meters per second square. Now don't write retardation as negative. Acceleration negative means it is retardation. Retardation is the English word for negative acceleration. So when you say retardation, you will say 2 meter per second square. But say suppose the problem had retardation given to you, and when you start doing the problem, you will take acceleration as negative, because acceleration is negative of retardation. So retardation is 2 meters per second square. One part of the answer is done, and we continue. F becomes equals to m into A. So m is how much? 2400 kgs multiplied by retardation, which is acceleration, which is A is equal to how much? Negative 2 meter per second square. So how much is the value you're getting? You're getting negative 4800 kg meter per second square, and you write F is equal to negative 4800 Newton. Now you need to give an explanation. What is this negative? So you write that negative F depicts retarding force. That is the force that is acting against the direction of motion, depicts retarding force. So my final answer would be retardation is equal to how much? 2 meters per second square. In bracket, you can write acceleration is negative 2 meter per second square, and retarding force is equal to 4800 Newton. See, I did not use the word negative because negative F depicts itself retarding force. So retarding force is 4800 Newton. So the vehicle is facing 4800 Newtons from this side and an acceleration of 2 meter per second square from this side. So the driver feels that there is a negative force of how much? 4800 Newton and a negative acceleration of 2 meter per second square, and he goes and stops up there. Right. So that's how we solve problems in which there should be clarity. We take some more problems of collisions, which will be interesting. I think they're not there now as per the new syllabus, but I hope this video gives you a fair bit of idea about how to solve problems and how to write and how to depict. Physics is all about understanding, depicting, and then inferring how your problem comes up. So see you again next time with another unit of collision, and we'll take your problems of collision. Until then, keep studying, happy practicing, and should you need more help in any other section of grade 9 physics, we feel free to drop down, and based on my availability, time and bandwidth, definitely like to help you all. Love you kiddos, get on with your new work. Bye-bye.